Okay, let's look at a specific reaction. We're going to look at oxygen gas reacting with hydrogen gas to produce explosively water gas. Now we have to make sure that we balance the equation. We have two oxygens over here, so we need to have two there, which makes us have to put a 2 in front of our hydrogen. Okay, so for our first question that we want to ask, we want to know how many moles of water are produced if, for example, we have 24.6 moles of oxygen and we have excess hydrogen. Okay, so we have 24.6 moles of oxygen, and that's a 1 that's understood to be there. For every 1 mole of oxygen, 2 moles of water are produced. So we set up our T-chart, and we're going to say 24.6 moles of oxygen. For every 1 mole of oxygen, there's 2 moles of water. Okay, so all we have to do is do our multiplication, and when we say 24 times 2, then, I'm sorry, and I left off my 0.6 there, but it's 24.6 times 2, we get 49.2 moles of oxygen. Okay, let's say then, for example, that we didn't want to go to moles of oxygen, moles of water, but let's say we wanted to go to grams of water. Okay, then if we wanted to go to grams of water, we can just erase this answer. We don't have to start over again. We're just going to add another part to our T-chart where we say, okay, well that's fine, because I know for every 1 mole of H2O, when oxygen is 16 and hydrogen is 2, I've got 18.0 grams of H2O. Okay, so 24.6 times 2 times 18 equals, here we have, whoops, didn't mean to draw a line right there. Here we have 18, I'm sorry, we have 85, so 886 grams of water. So notice how my moles of oxygen cancel, or my moles of water cancel, and we're left in grams of water, which is what we wanted to begin with. Okay? So let's say then, let's say that we were going to do another problem, and we're going to have, let's do 2 moles of sodium reacting with chlorine gas. We know chlorine's one of the diatomics, so it occurs as a diatomic to give sodium chloride. Solid. Okay, so if we have that, and let's say we are given that we have 3.4 moles of chlorine. Okay, if we have 3.4 moles of chlorine, and we have excess of sodium. So what we want to do is we want to get out of moles of chlorine, and let's say we want to get into grams, figure out how many grams of sodium chloride we're going to produce here. Okay, so we start with our T-chart, and we have 3.4 moles of Cl2. Okay, to get out of moles of Cl2, and into moles of chlorine, there's something that I forgot to do. I've got 2 chlorines here. I've got to put a 2 there to balance. For every 1 mole of chlorine, there's 2 moles of NaCl. Okay? Now, I didn't want to go to moles of NaCl. I'm out of moles of chlorine. I wanted to go from every 1 mole NaCl, there's 2 moles. Whoops. I've already done that part. For every 1 mole of NaCl, for NaCl, I need to get its molar mass. So sodium plus chlorine. Sodium is 23.0. Chlorine is 35.5. So I get 58.5 grams. So for every 1 mole of sodium chloride, I get 58.5 grams of sodium chloride. Now all I have to do is do my math. 3.4 times 2 times 58.5 equals, okay, 398. And notice we're in grams of sodium chloride. Okay, so stoichiometry problems aren't that hard. The thing that you need to remember is that you use your balanced equation to get out of one thing into another.